Greetings from Did You Know? Beneath the Earth's surface lie forces of unimaginable power. These forces are not just dormant, they are biding their time, waiting for the right conditions to unleash their might. These forces, capable of reshaping continents and altering life itself, are the mighty supervolcanoes. Their eruptions can blanket skies with ash, change climates, and even trigger mass extinctions. Unlike smaller volcanoes, supervolcanoes are geological titans, capable of eruptions thousands of times more powerful than anything witnessed in human history. They are the sleeping giants of our planet, and their awakening could have global consequences. The sheer scale of their potential impact makes them one of the most significant natural threats we face. These slumbering behemoths often appear as vast, serene landscapes, giving little hint of the cataclysmic power that lies beneath. Instead, they often lurk beneath seemingly placid landscapes, their presence betrayed only by subtle clues that geologists use to decipher their destructive potential. Yellowstone National Park, with its bubbling hot springs and geysers, sits atop one such giant. The park's geothermal features are a constant reminder of the immense heat and pressure building beneath the surface. Another lies dormant beneath Lake Toba in Indonesia, a serene reminder of an eruption that shook the world millennia ago. The study of supervolcanoes reveals the dynamic processes that shape our world. By understanding these processes, scientists hope to predict future eruptions and mitigate their impacts. It offers a glimpse into the forces that have shaped our planet over billions of years. From the formation of continents to the creation of new land, volcanic activity has played a crucial role in Earth's geological history. It is a tale of unimaginable power and potential for destruction, but also a testament to the resilience of life and the importance of understanding these natural wonders. What sets a supervolcano apart from its more common volcanic cousins? Is it just the size, or is there more to the story? The answer lies in the sheer scale and intensity of their eruptions, which dwarf those of regular volcanoes. Volcanologists use a scale called the Volcanic Explosivity Index, or VEI, to measure the intensity of volcanic eruptions. This scale helps scientists categorize eruptions based on the volume of material ejected, the height of the eruption column, and other factors. A typical volcanic eruption might register a VEI of 2 or 3, indicating a moderate level of explosivity. However, a supervolcano eruption blasts past this scale, reaching a staggering VEI of 8, which is exponentially more powerful. This difference in intensity reflects a fundamental difference in the volume of material ejected during an eruption. While a regular volcano might spew out a few cubic kilometers of ash and lava, a supervolcano eruption can unleash over 1,000 cubic kilometers of material into the atmosphere. Imagine an eruption so massive that it could bury entire continents in ash and alter global climate patterns for years to come. This is the kind of power a supervolcano holds. The sheer power of these eruptions arises from the unique nature of supervolcanoes. Unlike typical volcanoes, which are often characterized by a single cone-shaped mountain, supervolcanoes are much more complex. Instead of a single peak, supervolcanoes are characterized by massive underground magma chambers. These vast reservoirs of molten rock can build up over millennia, creating immense pressure beneath the Earth's crust. These magma chambers can extend for tens of kilometers beneath the Earth's surface, creating a ticking time bomb of geological proportions. When they finally erupt, the results are nothing short of catastrophic, reshaping landscapes and impacting life on a global scale. The formation of a supervolcano is a slow and inexorable process spanning millions of years. It holds the potential for unimaginable destruction. Driven by immense heat within the Earth's mantle, a plume of superheated rock rises, melting the overlying crustal rocks. This creates a vast pool of molten magma, rich in volatile gases, forming a magma chamber. As magma rises, pressure builds like steam in a pressure cooker, causing the crust to bulge upwards. This uplift is a visible sign of the subterranean forces at play, a stark reminder of the latent power below. When the pressure within a supervolcano's magma chamber finally exceeds the strength of the overlying crust, the result is a supereruption, an event of unimaginable violence and devastation. The eruption begins with a colossal explosion as the pressurized magma bursts through the weakened crust, sending a towering column of ash and gas high into the stratosphere. This initial blast is just the beginning. As the magma chamber empties, the overlying land collapses inwards, creating a massive crater known as a caldera. This caldera can be tens of kilometers wide, dwarfing the craters of even the largest conventional volcanoes. The collapse of the caldera triggers further eruptions, sending out shock waves that can be felt for thousands of kilometers. The eruption of a supervolcano is not a single event, but rather a prolonged period of intense volcanic activity lasting for weeks or even months. During this time, vast amounts of ash, rock fragments, and volcanic gases are ejected into the atmosphere, blanketing the surrounding landscape in a thick layer of volcanic debris. Throughout history, supervolcanoes have left an indelible mark on our planet. Imagine, if you will, an eruption so massive that it sends a colossal plume of ash and gas high into the atmosphere, darkening skies for miles around. The ground trembles as pyroclastic flows race across the landscape, engulfing everything in their path. These cataclysmic events have shaped the world we know today, reminding us of the incredible power that lies beneath our feet. Today, scientists use an array of advanced technologies to monitor supervolcanoes. These include satellite imagery, ground-based sensors, and even drones. By analyzing data from these sources, researchers can detect subtle changes in the Earth's crust, gas emissions, and seismic activity. This continuous monitoring helps us understand the behavior of these colossal geological features and hopefully predict future eruptions. Imagine, if you will, a supervolcano erupting in today's world. The sheer scale of the event would be unprecedented in human history. The immediate impact would be catastrophic, with ash clouds darkening the skies, disrupting air travel, and affecting global climate patterns. Crops would fail, and there would be significant loss of life. It's a scenario that, while terrifying, underscores the importance of our ongoing research and preparedness efforts. Preparing for a supervolcano eruption involves international cooperation and comprehensive planning. Governments and scientists work together to develop early warning systems and emergency response plans. Public education campaigns are crucial, ensuring that communities understand the risks and know how to respond. While we can't prevent such an event, we can certainly mitigate its impact through preparedness and resilience. Ultimately, supervolcanoes remind us of the immense power of our planet. They shape our landscapes, influence our climate, and challenge our perceptions of safety and permanence. By respecting and studying these natural wonders, we not only learn more about the Earth, but also about our place within it. It's a humbling reminder that despite all our advancements, we are still at the mercy of nature's incredible forces. Please subscribe and share to Did You Know? Gap 3S. As we conclude, let's turn our attention to one of the most famous supervolcanoes on the planet, Yellowstone. Nestled beneath the picturesque landscapes of Yellowstone National Park lies a colossal volcanic system that has erupted with unimaginable force in the distant past. This sleeping giant, with its boiling geysers and simmering hot springs, is a constant reminder of the raw power lurking just beneath our feet. Gap 2S scientists closely monitor Yellowstone's geothermal activities using cutting-edge technology to track ground deformation, gas emissions, and seismic activity. While the likelihood of another super-eruption in our lifetime is low, the potential impact of such an event would be catastrophic on a global scale. It would affect climate, agriculture, and even the very fabric of human society. Gap 2S. Understanding. Yellowstone isn't just about predicting the next eruption, it's about appreciating the dynamic processes that shape our world. Each hot spring and geyser tells a story millions of years in the making, a testament to the ever-changing nature of our planet. Gap 2S. So next time you visit Yellowstone, take a moment to reflect on the immense forces at play beneath your feet. Remember that our planet is alive, constantly evolving, and that we are but small characters in its grand narrative. Thank you for watching. Please subscribe and share to Did You Know? Gap 2S. To truly appreciate Yellowstone's supervolcano, we must delve into its intricate geology. The volcanic activity in Yellowstone is driven by a hotspot, a plume of hot material rising from deep within the Earth's mantle. This hotspot has been stationary for millions of years, while the North American plate slowly drifts over it. Gap 2S. As the plate moves, the hotspot creates a trail of volcanic features, including the ancient calderas that formed during past supereruptions. The Yellowstone caldera, the most recent and active, formed around 640,000 years ago during a massive eruption that ejected over 1,000 cubic kilometers of volcanic material. Gap 2S. This eruption left behind a vast caldera, a depression that spans approximately 30 by 45 miles, now filled with geothermal wonders. The caldera's floor is a mosaic of lava flows, hydrothermal vents and geysers, each contributing to Yellowstone's unique landscape. Gap 2S. The park's iconic features, such as the Grand Prismatic Spring and Old Faithful, owe their existence to the underlying volcanic activity. These geothermal features are fueled by the heat from the still-active magma chamber beneath the surface. Gap 2S. Understanding the geology of Yellowstone not only enhances our appreciation of its beauty, but also underscores the importance of monitoring and studying such dynamic systems. The interplay between geological processes and surface features provides valuable insights into the Earth's history and future. Gap 2S. So as you marvel at Yellowstone's stunning landscapes, remember the powerful geological forces that continue to shape this remarkable region. Thank you for watching. Please subscribe and share to Did You Know? Yellowstone's eruptive history is a testament to the raw power and unpredictable nature of supervolcanoes. Over the past 2.1 million years, Yellowstone has experienced 3 cataclysmic eruptions. Each of these eruptions was thousands of times more powerful than the 1980 eruption of Mount St. Helens. The first of these supereruptions occurred about 2.1 million years ago, creating the Huckleberry Ridge Tuff and forming a caldera that spans approximately 60 miles across. This eruption was so massive that it ejected nearly 2,500 cubic kilometers of volcanic material into the atmosphere, influencing global climate patterns for years to come. The second major eruption happened around 1.3 million years ago, forming the smaller but still significant Island Park caldera. This event released about 280 cubic kilometers of volcanic material, reshaping the landscape and leaving behind a legacy of geological features. The most recent supereruption, about 640,000 years ago, produced the Lava Creek Tuff and created the Yellowstone caldera we see today. This eruption was responsible for spewing over 1,000 cubic kilometers of ash and debris, impacting ecosystems far beyond the park's boundaries. In addition to these supereruptions, Yellowstone has experienced numerous smaller eruptions and lava flows, each contributing to the complex and dynamic geology of the region. These events have shaped the park's terrain, creating the diverse and awe-inspiring landscapes that draw millions of visitors each year. As we study Yellowstone's eruptive history, we gain valuable insights into the behavior of supervolcanoes and the potential risks they pose. By understanding the past, we can better prepare for the future and develop strategies to mitigate the impacts of any future eruptions. So the next time you visit Yellowstone, take a moment to reflect on its turbulent past. The park's beauty is a reminder of the powerful forces that have shaped our planet and continue to influence our world today. Yellowstone's eruptions have profoundly impacted the environment. Supereruptions over 2.1 million years left marks on local and global scales. The Huckleberry Ridge Tuff eruption changed the landscape and climate. Volcanic ash and gases caused climatic repercussions. A volcanic winter likely followed, disrupting ecosystems. The Island Park caldera eruption had widespread effects. Ash clouds spread, affecting air quality and weather. Ecosystems were altered, forcing species to adapt. The Lava Creek Tuff eruption was cataclysmic. Ash and debris had far-reaching consequences. Crops failed, skies darkened, and temperatures dropped. The eruption likely caused significant climatic cooling. Smaller eruptions also shaped the environment. These events created fertile soils and new habitats. Yellowstone is a dynamic system constantly evolving. Understanding these eruptions shows Earth's interconnected systems. Monitoring and preparing for future activity is crucial. Insights from Yellowstone's past are crucial for our future. Yellowstone's history reminds us of nature's resilience and power. Monitoring Yellowstone's volcanic activity is crucial. Scientists use advanced technology and careful observation. The Yellowstone Volcano Observatory leads this effort. Seismic activity is a key indicator of volcanic unrest. Seismometers detect even the slightest tremors. These instruments provide real-time data. Analyzing patterns reveals magma movement. Ground deformation is another critical aspect. GPS and radar measure surface changes. Uplift or subsidence signals magma intrusion. Subtle shifts offer clues about the magma chamber. Gas emissions are vital. Gases like carbon dioxide and sulfur dioxide are measured. Changes in gas composition indicate rising magma. This helps assess eruption potential and impact. Thermal imaging provides additional data. Heat signatures identify hotspots. These technologies reveal patterns. Public awareness is essential. Visitor centers educate parkgoers. Regular updates keep the public informed. Predicting eruptions remains a challenge. Continuous monitoring provides early warnings. It allows timely alerts, minimizing risks. Advancing our understanding equips us better. Monitoring efforts safeguard Yellowstone and its people. Vigilance and inquiry ensure a safer future. As we continue our journey into the heart of Yellowstone, we turn our gaze towards the future. What does the future hold for this magnificent yet formidable supervolcano? The answers lie in the hands of science and our collective efforts to understand and respect the forces at play beneath the Earth's crust. Cutting-edge research and innovative monitoring techniques provide a clearer picture of the volcanic processes that shape this dynamic landscape. With each new discovery, we gain valuable insights that help us predict and prepare for potential eruptions. The future of Yellowstone is not solely in the realm of science. It is also a matter of public awareness and preparedness. Communities living in the vicinity of Yellowstone must be equipped with knowledge and resources to respond effectively in the event of volcanic activity. Education and outreach programs play a crucial role in fostering a culture of resilience and readiness. The preservation of Yellowstone's natural beauty and ecological integrity is another vital aspect of its future. Conservation efforts aim to protect the diverse wildlife and unique geothermal features that make this national park a treasure trove of biodiversity and wonder. Sustainable tourism practices ensure that future generations can continue to marvel at Yellowstone's splendor without compromising its delicate balance. As we look ahead, it is essential to recognize that Yellowstone's power is a reminder of Earth's dynamic nature. The supervolcano beneath our feet is a testament to the planet's ever-changing landscape. By embracing the spirit of scientific inquiry and fostering a sense of respect for nature's might, we can coexist with Yellowstone and harness its lessons for a safer and more informed future. The story of Yellowstone is far from over. It is a story of discovery, resilience, and the enduring bond between humanity and the natural world. As we stand on the brink of new horizons, we hold the key to unlocking the mysteries of this geological giant and ensuring its legacy for generations to come. The future of Yellowstone is a story of discovery, resilience, and the enduring bond between humanity and the natural world. Yellowstone is a vibrant tapestry of life, teeming with diverse ecosystems and wildlife. From lush forests and meadows to bubbling geysers and thermal springs, the park is a sanctuary for myriad species. Majestic bison roam freely, embodying the spirit of the wild. Once near extinction, bison have made a remarkable comeback thanks to conservation efforts. Their presence is a testament to nature's resilience and successful human intervention. Wolves, reintroduced in the 1990s, have reshaped the landscape. As apex predators, they maintain ecosystem health by controlling prey populations. This trophic cascade highlights Yellowstone's intricate web of life. The park's rivers and lakes host diverse aquatic life, including the iconic Yellowstone cutthroat trout. These waters provide vital habitats, contributing to the region's biodiversity. The balance of these ecosystems reflects the park's pristine state. Birdwatchers are drawn to Yellowstone for its rich avian diversity. From bald eagles to great grey owls, the park is a haven for rare bird species. The symphony of bird calls and sight of eagles in flight leave lasting impressions. Geothermal features create unique microhabitats supporting specialized organisms. Thermophilic bacteria thrive in hot springs, showcasing life's adaptability. These organisms hold clues to understanding life's resilience on Earth and beyond. As stewards, we must protect and preserve Yellowstone's ecosystems and wildlife. Sustainable tourism, research, and conservation are essential for future generations. Yellowstone's story is one of interconnectedness, where every being plays a role. By safeguarding this web, we honor one of Earth's most extraordinary treasures. Yellowstone is a living testament to the beauty and complexity of the natural world. It is a place where nature's forces and life's wonders converge, reminding us of our bond with Earth. Yellowstone National Park, a crown jewel of natural beauty and geological wonders, attracts millions of visitors each year. Tourists flock to witness its breathtaking landscapes, vibrant ecosystems, and unique geothermal features. Yet with great admiration comes great responsibility. The balance between tourism and conservation is a delicate one, requiring thoughtful management and active participation from all who visit. As visitors traverse the park's meandering trails, they are reminded of the importance of treading lightly. Staying on designated paths not only ensures personal safety but also protects fragile habitats from damage. The leave no trace principles guide every step, encouraging visitors to leave the park as pristine as they found it. The park's infrastructure, from boardwalks around geysers to educational visitor centers, plays a pivotal role in sustainable tourism. These facilities are designed to minimize human impact while maximizing the educational experience. Interactive exhibits and ranger-led programs foster a deeper understanding of Yellowstone's natural and cultural heritage, inspiring a new generation of conservationists. Volunteer programs offer another avenue for stewardship. Visitors can participate in habitat restoration projects, wildlife monitoring, and trail maintenance, contributing directly to the park's preservation. These hands-on experiences not only benefit Yellowstone, but also instill a sense of ownership and responsibility in participants. Conservation efforts extend beyond the park's boundaries. Collaborative initiatives with surrounding communities and organizations aim to protect the greater Yellowstone ecosystem. Wildlife corridors, sustainable land use practices, and scientific research are integral to maintaining the health and connectivity of this vast and diverse region. The park's management employs cutting-edge technology to monitor environmental changes and manage visitor impact. Remote sensing, GPS tracking, and data analytics provide valuable insights into patterns of use and ecological health. This information guides adaptive management strategies, ensuring that Yellowstone remains resilient in the face of growing tourism and environmental challenges. The story of Yellowstone is one of coexistence, where human presence harmonizes with the natural world. By embracing sustainable tourism practices and supporting conservation efforts, we can ensure that this iconic landscape continues to thrive. Yellowstone's beauty and biodiversity are treasures that belong to all of humanity, and it is our collective duty to protect them. In the end, the future of Yellowstone depends on the choices we make today. As stewards of this magnificent park, we have the power to shape its legacy. By respecting its wonders and nurturing its ecosystems, we honor the profound bond we share with nature and ensure that Yellowstone remains a source of inspiration and wonder for generations to come. Yellowstone National Park is shrouded in both wonder and mystery, giving rise to numerous myths and misconceptions. Today, we dive into some of the most common myths and uncover the facts behind them. Myth 1. Yellowstone is overdue for a supereruption. Fact: geological activity does not follow a strict timetable. Scientists see no signs of an imminent supereruption. Myth 2. The entire park is a volcano. Fact: Yellowstone is a diverse landscape of mountains, rivers, forests, and geothermal features. The volcanic activity is concentrated in specific areas. Myth 3. All of Yellowstone's geysers erupt regularly. Fact: many of Yellowstone's geysers are far less predictable. Some erupt sporadically, while others may remain dormant for years. Each geyser has its own unique pattern and cycle. Myth 4. Yellowstone's wildlife is tame and approachable. Fact: Yellowstone's wildlife remains wild and unpredictable. It is crucial to maintain a safe distance and respect their natural behavior. Myth 5. The park is closed during winter. Fact: the park remains open year-round. Winter offers a unique opportunity to experience Yellowstone's snowy landscapes, hot springs, and wildlife. Myth 6. You can swim in Yellowstone's hot springs. Fact: swimming in Yellowstone's hot springs is not only prohibited, but also extremely dangerous. The water temperatures and chemical compositions can be hazardous to human health. Designated swimming areas such as the boiling river offer safer alternatives. Myth 7. Yellowstone is only about geothermal features. Fact: Yellowstone is also home to diverse ecosystems, rich cultural history, and stunning landscapes. From the Grand Canyon of the Yellowstone to the vast Lamar Valley, there is much more to explore beyond the geothermal wonders. By separating myths from facts, we gain a deeper appreciation for the true marvels of Yellowstone National Park. Understanding the realities of this extraordinary place helps us protect and preserve it for future generations. As we continue to explore and learn, let us celebrate the authentic beauty and complexity of Yellowstone, a testament to the power and wonder of our natural world. As we delve deeper into the wonders and mysteries of Yellowstone National Park, it's essential to address the question on everyone's mind: how can we prepare for a potential eruption of the Yellowstone supervolcano? Firstly, it's important to understand that scientists are continually monitoring Yellowstone's volcanic activity. Advanced technologies such as seismographs, GPS stations, and satellite imagery helps detect even the slightest changes in the Earth's crust. These tools allow experts to predict possible eruptions with greater accuracy and provide early warnings to mitigate potential disasters. Public awareness and education are also crucial. Knowing the signs of volcanic activity, such as increased seismic activity, ground deformation, and gas emissions, can help individuals stay informed. Emergency preparedness plans should be in place for communities within the potential impact zone. These plans include evacuation routes, designated shelters, and communication strategies to ensure the safety of residents and visitors. On a broader scale, governments and organizations must collaborate to develop comprehensive response strategies. This includes stockpiling essential supplies, coordinating with emergency services, and conducting regular drills to ensure readiness. International cooperation is also vital, as the effects of a supereruption could extend far beyond national borders. While the likelihood of a Yellowstone supereruption occurring in our lifetime remains low, being prepared can save lives and minimize damage. By staying informed and vigilant, we can coexist with the powerful forces of nature that shape our world. In the end, preparing for a potential Yellowstone eruption isn't just about safeguarding ourselves, it's about respecting and understanding the dynamic planet we call home. As we continue to explore and protect Yellowstone, let us also remember the importance of preparation and resilience in the face of nature's unpredictability. As we conclude our journey through the awe-inspiring and formidable landscape of Yellowstone National Park, it's clear that this region is a testament to the raw power and beauty of our planet. From its breathtaking geysers and hot springs to the hidden depths of the supervolcano beneath, Yellowstone serves as a powerful reminder of Earth's dynamic nature. Throughout this exploration, we've delved into the science behind supervolcanoes, the historical context of Yellowstone's eruptions, and the advanced monitoring techniques that keep us informed. We've imagined the potential impact of a modern supereruption and discussed the critical importance of preparedness and resilience. But beyond the science and the strategies, Yellowstone also offers us a deeper lesson. It teaches us about the interconnectedness of all life, the delicate balance of ecosystems, and the profound respect we must have for the natural world. As we stand in awe of Yellowstone's power, let us also be inspired by its beauty and resilience. Let this journey remind us of our responsibility to protect and cherish the wonders of our planet. For in understanding and respecting the forces that shape our world, we can better prepare for whatever the future may hold. Thank you for joining us on this incredible journey through Yellowstone. Stay curious, stay informed, and always respect the power of nature.